Hey guys, welcome to another episode of Trying to Learn C Programming. So, in case you don't know what is happening, I am trying to learn C programming, and how I intend on doing that is by creating some 50 programs I got from ChatGPT. So far, episode 1 through 7, I have done 14 of them, which is approximately 2 per episode, and I'm going to continue from where I stopped. So, the next one is implementing linear and binary search for an array of integers. Okay, so how I do this is for every project I create a directory. So I will just create a new directory called search, then cd into search. I'm coming, then cd into search. Then so currently I am inside a tmux session. You can see from down here I am inside a tmux session. So what I do is for this, at the first window, that's where my main code is, and for the second, that's where I run my binary, my executable. So let me just main.c. Then I'm just trying to create my main function. So this is my main function. So you can just go. So let's see. So what am I supposed to do? Linear and binary search for array of integers. Implement linear and binary search for int array. Okay, so I can just have two functions. Let's say linear, then we can have another function, binary. Okay, so this is my building block. So let me open the project here. Search. So I need, because I really have no idea. Let me first see the difference between linear and binary search. Linear search. Google.com has some security issues. The issue is most likely with the website. Okay, I'm coming. Let me change my search engine. Binary search. Alright, that worked. Alright, so I'm coming to Wikipedia. My internet is not the fastest, so that's why it is taking long. Okay. In computer science, binary search is a search algorithm that finds the position of a target value within a sorted array. Binary search compares the target value to the middle element of the, if they are not equal. Wait. I first need to I am first going to implement linear search before binary. It's the first one. That's how I want to do it. It looks a bit easier. Linear search, of finding an element within it. It sequentially checks each element of the list until a match is found or the whole list has been searched. So this is the basic algorithm. Your I would be equal to 0, then if the list at that position is equal to your whatever you're searching successful, you return I. Increase I by 1, else. Alright. Okay, I think I know how it is. So how am I going to do this? Maybe the function, each function should have two. I'm thinking each function should have maybe two parameters. two parameters. Then one would be array of ints. Then the second would be int to search. Yeah. So let's see. So let's say we have int, then num array, it took in a number array, and then int number to search. So this is the number to search. So how it is it is basically a for loop. Int I is equal to 0, then I is less than I is then you have I plus plus. I am coming. Okay, I don't think that's possible. So how do you find the length of a number array? I am coming. Length of num array in C. I don't know why Google search engine is acting up. Store size, the size of array, the length of the array is, so it is size of array over size. Okay, I am coming. So you can just do ng length is equal to size of num array size of num array 0 size of return the size of the pointer, not the array. Did I do something wrong? I'm coming. Let me check this Stack Overflow. It's like I'm doing something wrong because what is this, bro? Let me remove this. So we just go I is less than length. Oh, does it have to be this size T? I don't even know what that is. God. Size of A over size of int, and you can use it to make sure your code not to be hard coded to int. Say you have an array, you just need what is up like this, bruh. What is the num like this. Sorry about that. Okay. If it's a character array, an integer called my array, size of I don't know. Okay, this is just a warning. I don't think there's anything there. So let me continue. So linear, then you go if, then you go the num array of I is equal to num printf element found at position, then you go percentage d. So I is the position, then you break. Wait, I don't want to break, because what if the elements appears more than, let's say, once? So I need to know where it is. So I think this should do it. So let's go linear, then we can do it. So I can, let me see, so I can reuse it. So let's say int, then we go array, then we have 1 comma 5 comma 2. All right, then we go linear, then you have array, then you have 42. So would this work? So let me come here, create. Oh, it is not working. So this one in here, so let's see. Length, so we go int, this work? No, still not working. So how do I get the length of the array, the size of the array? So let's see. array length, size of the array over size of the array. That's exactly what I have here. Like what? Length. It's exactly the same thing. So here, how am I supposed to do this? Since it will return the pointer with this. So we can go. I have no idea what I'm doing at this point. I'm just trying to. Let me see if I can get size of. This is equivalent to query. The intent of the program, get the integer and not its size. What? Bro, what is this? This is actually more complicated than it should be. What is this? Let me try something I saw earlier. Still doesn't work. Let me remove this second part and see what happens. Still, on array function parameter will return size of the int pointer instead of array. So is this supposed to be pointer? So wait, I'm coming. What if I return that size of pointer to number array? Okay. One, two, three. So let me try this and see. Oh, it works. Wow. Man, this thing is weird. Is it that this documentation is old, or when was this updated? Is it that yeah, it's up to date 2024. So why? Maybe I don't need to do the slash size of array at index 0. Let me just do printf. Let me print the length and see what happens, what it prints. 4, 1, 2. But I actually have 5 elements. Okay, since it's an array, it starts at 0. So if I need to get the true length, I just do length plus 1. I think that would work. So let's do, yeah, 5. Then you have the element is found at, let me just, array position. Yeah. So element found at, okay, let me print. I should print the array. Printf, then percentage. Oh, let me see how to do this. Print array in C. So I need to specify the position or what? How do I print the whole array? Oh, C is getting on my nerves. Not the position, the whole shebang. That's that. But I got this. So it is at array position 2. So 42, you have 0, 1, 2. So I need to know if, what if it's not in the list? Let me see what happens if what I'm looking for is not on the list. So let's try 4. 4 is not on the list. Nothing happens. So let's see. I know how to, let me show you how to handle that. You just do bool. There's no boolean inside this language. Is this boolean found equals to I'm coming. I have this wonderful, let me see if there are booleans here. I don't think they are. So let me just come. Boolean in C. So I need to import it. So we go hashtag include std bool. There you go. So I can just do this. So we can just come here after the for loop is done. If not found, then you go printf element not found in array, new line. So let's go cc create the executable element not found in array. So let's just do 42 and see what happens. Cc, boom. So I think that's it for linear search. So now I have to do binary search. I am done with linear search. So let me see how does binary search. Let me just remove all this. Binary search. The reason why I left earlier, I saw that for binary search you first have to sort the array. It compares the target value to the middle element of the array. If they are not equal, the half in which the target cannot lie is eliminated and the search continues on the remaining half. Okay, I think I know how it works. So let's say you have this. So the first thing that happens, this array gets sorted. So let's say, I am coming, let me sort it. So you would have something like 1, 2, 5, 42, 54. Okay, now that it is sorted, you will now come to the middle element. You are looking for 42, you now come to the middle element. If the middle element is 42, then you have found the element you're looking for and your search is done. Bam, bam. If it is not 42, you now check, is it less than 42? If it is less than 42, this right half gets eliminated. If it is greater than 42, the left half gets eliminated, and you continue this search until your array is reduced to 1. Then you compare, and if it is not, then you haven't found anything. Boom. Binary search. Binary search works on sorted arrays. It begins by comparing an element in the middle of the array with the target value, just what I explained. If the target matches the element, the position is returned. If it is less than the element, it continues in the lower half of the array. If it is greater than upper half. Alright, so this is the procedure. So let me look at the algorithm. You have A, N, and T. I'm coming. Given an array A of n elements, so A is your array, n is the length of the array, the size, sorted such that A is less than or equal to A1. Yeah, it is sorted. A is the smallest and an minus 1 is the largest element, and the target value T. Okay, then you have your left is equal to 0, your right is n minus 1. That's the length minus 1. That's the last element. So your left is the first element, your array is the last element. While left is less than or equal to r, do what is position of the middle element. M is equal to floor left plus R over 2. If okay, let me code this. So you have int yeah, just the same as the above one. Then you have g. The length is the size of the pointer to the num array. Alright, then you have your left to be equal to 0, right, with int left 0, right is equal to length. So the reason why I am not doing length minus 1 is because, like I stated up here, if you were to print the length, you get the exact length that's in the order they are in the array, and if you wanted, that's with 0 being the first. 0 being the first. So length gives you the true length of the array, how it should be. So I don't need to do minus 1 or plus 1 or anything. It's just there. Then you go while left is less than left is less than while left is less than then the middle is equal to, do I have a floor function? How does this floor work? Floor left plus right divide by 2. Result of integer division used in a floating point context, possible loss of precision. I know that. Then you go, then you now check inside your number array. If num array at middle is equal to then you can just do at position middle, no, not position middle, yeah, position middle, then you can just break, you can just exit, you have found it. Then, but what if you have not found it? Else, no, I'm coming. Yeah, else if num-array, else if, so if I have not found it, sorry about that, else if num-array else if the number you're looking for is greater than is greater than the num-array at middle. So what happens if your target is greater than, then you, if it is greater than, then your rights, if it is greater than, then your rights is equal to middle minus 1. Oh, so the moment you change your, you change your right and left, you are changing the searching scope. Yeah, that's what is happening. So if it's, oh my god, why do I keep doing that? So if it is not your middle number and it is greater than, it is definitely less than. So if it is less than, you are changing your left. So left would be equal to middle plus 1. So I am coming. So let's do binary. So what is going to happen? I am going to feed it a sorted array int, and the reason why I'm going to do that is because I saw that the next thing I am going to have to do is sorting. So why jump the gun? So I'll just wait and learn it then. That would be much easier, or it would be much more better. So let's do 1 comma 2 comma 5 comma 76 comma 85 comma 40 99. Then you have sorted. Then let's look for 99. Oh, okay, I think I don't follow this algorithm, though. Let me just follow it. So if array at, if the element at the middle is less than the target, that's the first if element at middle is less than the target, then what should happen? If it is less than the target, then that's the if it is less than the target, then you are incrementing your left. If it is greater than element at middle is greater than the target, element at middle, if it is less than the target, increasing your left. If it is greater than the target, you're reducing your right. If it is greater than whatever is in the middle, sorry, if whatever is in the middle is greater than I mixed them up. Alright, that should do it. So let's do printf element found at position, then you have percentage d middle, so let me try that, so help me God. I am coming. Before I do that, let me just remove this linear. So let me try 5 and see. Oh my god, bro, what? I need to. Okay. So that was a do while loop. Wait. P left is less than. Would this work? Bro, what was that about? I need to break out of this loop. I need to escape. Element found at position 2. So why couldn't it find 99? So let's see if I can find 99. Nope. What of 85? If I can find 85, then I think I might know where the problem is. Nope. '76. So So what is happening is 0, 1, 2, 3. So it is not searching the right side of the array for some reason. So let's see if the number at the middle is less than your target, then your left should be your middle plus 1. That's correct. If the number at the middle is greater than whatever your target is, then your right should be moved. Else, while left is less than or equals, that could be the problem. Definitely not. So let's see 85. Element found at position 4. 1, 2, 3, 4. And why am I not able to search for 99? Okay, that's very weird. Or is it because of this? Let me add +1 and see if I can get position 5. Oh, so I guess I needed the +1. And now I cannot find. Oh, 88 is not inside. So I will handle that in a minute. Okay. Else. So I will do the same thing I did up there. So you can just bool found is equal to false. This is just a hack. I will get better with time, hopefully. Then you can come found is equal to true. Then you can come down here. If not found, element not in array, new line. So 86 is not in the array. So when I do this, element not in the array, and when I change this to 85, element at position 4. So I think voila, I just implemented linear and binary search. So let me add this linear and binary search done, then git push and come. So that's it. I am done with implementing linear and binary search for an array of integers. So in my next episode, I am going to continue with sorting. I'll go through bubble selection and insertion sort algorithms. So, just to recap what I learned today, I learned linear search. It just goes linearly checking each and every list from the first item to the last. While I think binary search should be faster because it breaks the list into two. But before you're able to do binary search, your array has to be sorted. We'll cover that in the next episode. And I think that's it. So thank you for watching. See you on the next episode. Bye.